Hello, my little triglets. Ready to move onward and upward? Today we're going to talk about section 6.3. And we're going to have some new formulas for you. They're going to be called double angle formulas. We're also going to talk about half angle formulas, but that's not until next time. A double angle formula is used when you want to model several motions with one equation. So if you have a sideways motion and an up motion or a down motion, you can combine them into a double angle and use it in that formula. Now the double angle formulas came from the sum and difference formulas, and I'll show you that. If I have the sine of a plus b, we all know those, sine has same sign, so sine a cosine b plus cosine a sine b. Now what if I change this to sine of a plus a, which would be sine of 2a, or a double angle? Well, all these b's would turn to a's. So I would really have sine a cosine a, cosine a, sine a. Now these are technically the same, they're just reversed from each other. So the double angle formula that we're going to use is, if I put these two together, that will be two of them, 2 sine a cosine a. So that is the formula for sine 2a. And yes, you have to memorize that. Okay, so we're going to have to memorize double angles. But if you forget them, you can always go back to the sum and difference and do what I just did. Now their cosine double angle, we could go through the same scenario. Remember, cosine is cosine, cosine, sine, sine. So really, it's going to be cosine squared a minus sine squared a. So there's the cosine double angle. There's a couple other versions of it, because we know Pythagorean theorem, we know that sine squared plus cosine squared equals 1. I could replace either one of these with the equivalent part of that one. So there are two other versions. I'm just going to write them down here. One of them is 1 minus 2 sine squared a. The other one is 2 cosine squared a minus 1. Now you can use any one of them that you want. If you only have sine, you might want to use this one. If you only have cosine in the problem, you might want to use that one. But you can always find the other ones. Now tangent formula, let's go to the next page. Tangent of 2a is equal to 2 tangent a and then 1 minus tangent squared. So it looks a lot like the sum and difference, but we've combined the two things. All right, again, you have to memorize that one. All right, let's do a problem here to utilize all three of these. If you are given that the cosine of theta is negative 5/13 and it's in the second quadrant, I want you to find sine 2a, cosine 2a, and tangent of 2a. All right, when they tell you the quadrant, that's your clue that you probably should draw it and put a triangle in there. So second quadrant. Cosine, remember, is x over r. So this is negative 5, this is 13. It's a 5, 12, 13 triangle, so now we know what y is. All right, formulas. Sine 2a is 2 sine a cosine a. So plugging in the sine of this angle a, I should probably make this a. Whoa, we'll go back just to make it usable. Never mind. So 2 sine A, cosine A. Sine A is y over r, so 12. Boy, this is really freaking out here. We have 12 over 13. So y over r. Cosine A, they already gave us, is negative 513. So put a 1 under here, multiply straight across, and I get 24 times 5 would be negative 120 on the top, 169 on the bottom. So that's the sine of 2a. All right, cosine of 2a. We have our choices and formulas. I'm going to use the original one, cosine squared minus sine squared, since I already have those values. Cosine of a, we said was negative 5/13. Got to square it. Sine of a, we said was 12/13. Got to square that. And then let's simplify here. I've got 25 1/69 minus 144 1/69. So I get negative 119 1/69. Okay, so those are those two answers. Now we got to go to tangent. I'm going to go to the next page and rewrite some of the information that we have. That the cosine is negative 5/13. Quadrant 2, so negative 5, 13, and 12. All right, tangent of 2a is 2 tangent a over 1 minus tangent squared a. All right, tangent is y over x, so 12 over negative 5. And then 1 minus 12 over negative 5 squared. So on the top, this is 2 over 1, so 24 over negative 5. On the bottom, I get 1 minus, squaring the parentheses, 144 over 25. Now my advice is to change all the denominators to the same thing. So I'm going to multiply this by 5, and I'm going to change this 1 to 25 over 25. When you do that, now the top is negative 24 over, nope, I take that back. It's going to be negative 120 because 24 times 5 is 120. So negative 120 over 25 over 25 minus 144 over 25. Cancel the denominators, so I get negative 120 over 119. Okay, so that's how you do tangent of 2a. Now I want to go back a page and have you notice something. The two answers I got, look at the numerators, 120 and 119. Go back here, 120 and 119. Technically that's a minus. So 120 over 119 is the answer because it's sine over cosine. So instead of going through all of this rigmarole, you could just take sine over cosine and reduce them, and you'll get that. So it's up to you. If you're just given tangent, then you got to do it this way. If you're given all three, you can use sine and cosine to get your tangent. All right, so that's double angles, and I'm going to wait to do half angles the next time. So in the meantime, don't forget, Trig Love will take you to places beyond your wildest dreams. Ta-ta for now.